Today, we are presenting to you our capstone project, Polytechnic University of the Philippines Taguig Inventory Management System, presented by our team, Days.
I'm Casey Escobia, the full stack developer of our team.
I am Eric Fido, the front-end developer.
I am Alisa Tabang Banua, the project manager and document analyst.
And I'm Dina Saldaven, quality assurance.
In today's presentation, we will look into the key components of our research and system development. So, as we start, here are the table of contents. First, we will discuss the introduction. Next, review of literature and studies. Next, methodology, resultant discussions, conclusion and recommendations, and lastly, the implementation details. As we discuss our system, PUP-Taguig Inventory Management System, I would like to present to you our client, Polytechnic University of the Philippines Taguig Campus, our specific client, which is Prof. Gina de la Cruz, which is the property custodian of PUP-Taguig, and Sir Ronilo Lim, the laboratory custodian or the system administrator. So our client, PUP-Taguig Campus, is located in General Santos Avenue, Lower Bicutan, Taguig City, Metro Manila. So the nature of the company of PUP-Taguig is that it provides a quality education. It is a government fund institution. It promotes a transparency, accuracy, and proper management of school resources. What is PUPT-IMS? PUPT-IMS, or Inventory Management System created for Polytechnic University of the Philippines Taguig Campus, is a computerized system that helps the university organize, monitor, and manage its equipment and assets efficiently. So instead of using logbooks or spreadsheets, it automates the process. So it allows the authorized users, which are the office heads, property custodian, and super admin that process the maintenance. It easily helps them to add and update records. So they track equipment status, generate reports, and scan QR codes to access item details. So overall, the system helps streamline the asset management, reduce errors, and make inventory handling faster and more accurate.
This figure illustrates the problem of tracking inventory, assigning and keeping accurate records. So this is a fishbowl, or also known as the cause and effect diagram, in which we have here the contributing factors: the people, method, environment, and the equipment itself. So for the people, we know we as a humans are prone to have errors, and for method, we have a manual and lengthy process, dependence on physical records, no tracking mechanism, and lack of inventory records. For the environment, we also have a reliance on physical records contributing to paper waste. And for the equipment itself, we also have a reliance on paper, inefficient process, and prone to lose. So just imagine you have important records and you just put it on the paper. So when that paper lost, all your important records will be lost along with it. So that's why we came up with this proposed process to address these challenges and to have a accurate data and fix the current problem of our study.
The main objective is to develop a system that will make inventory tracking more efficient, accurate, and secure, using QR codes for faster equipment verification, enabling real-time updates and reports, implementing role-based access for security, and supporting better auditing and monitoring across departments.
In this video, we will present to you the proposed process flow of the Polytechnic University of the Philippines Taguig Inventory Management System. The flow we'll be showing involves three key roles: the laboratory custodian or maintenance, the office heads, and the property custodian. The process begins with the laboratory custodian or maintenance personnel. They start by creating accounts for both the admin and users in the system. Once the accounts are created, the account credentials is automatically sent to the respective users so they can access the website. Afterward, the flow connects to the office heads and property custodian roles to proceed with inventory management and distribution. Next, we have the office heads. They begin by accessing the website using the credentials provided. Once logged in, they will check whether they are a laboratory custodian or not. If no, they can view the inventory records of their assigned office directly. They can also review the pending section to see if there are newly distributed pieces of equipment awaiting verification. To verify, the office head will scan the QR codes in the transfer form and check if all the listed equipment is complete. If all items are verified, they will accept the equipment in the pending section of the system, then receive and sign the transfer report. However, if any discrepancy is found, they will report the issue to the admin and super admin and deny the equipment in the pending section. Now, let's move on to the property custodian. The property custodian is responsible for inserting all inventory data from the PUP main printed sheet into the system. After encoding the information, they will transfer the equipment to the respective offices using the system. Before distribution, the system generates a transfer form, which must be printed and signed to confirm the release. Once this step is completed, the process flow ends, signifying that the equipment has been properly transferred, verified, and recorded within the system.
Efficient inventory management is crucial in schools to ensure proper handling resources. However, many institutions still rely on manual systems, which lead to errors, delay, poor tracking, and this chapter reviews 3 related studies that highlight the limitation of such systems. First is Basilan and Besa 2019 pointed out the lack of manpower and reliance on manual tracking in schools, resulting in inefficient and frequent human error. Second is Rodriguez 2024 emphasized issues like inaccurate data entry and poor record keeping, but didn't propose technological solutions to improve the system. Lastly, Frida 2024 studied foreign schools and found similar problems, yet continued to focus on manual process without automation or digital tools. Across all studies, common gaps include no real-time tracking, lack of automation, high risk of human error, unstructured and outdated process.
I will be discussing the Chapter 3, which focuses on the methodology of our study. So for research design, our study uses the descriptive developmental research design. The descriptive part was used to describe the current system, its current process, and the problems encountered. The developmental part was used to create and improve the proposed system to address those problems. We also applied quantitative method, which involves collecting numerical data such as ratings and evaluation scores from the UAT. Next is the sampling technique. We use the purposive sampling technique. This means that we intentionally selected individuals who are directly related to or knowledgeable about the system. In other words, only the people who use or manage the system were chosen as respondents. For software development process, we use the Agile methodology. It uses the iterative development where the system is created and is enhanced or improved in short cycles called sprints. This allowed us to gather feedback quickly and make adjustments and continuously enhance the system until it meets the user's quality standards. Now let's talk about the foundations of our project. We use PHP and JavaScript. PHP for the user-side language and JavaScript for user-facing aspects of the application. For database, we use MySQL. For development frameworks on the backend, we use the Laravel, and for front-end styling, we use Tailwind CSS. For gathering initial requirements, user testing data, we use both Google Forms and printed forms. For data gathering and evaluation, we use the ISO 25010 software quality model and conducted UAT or the user acceptance testing. The ISO 25010 model was used to assess the software based on its quality factors. Meanwhile, the UAT allowed the actual users to try the system and provide their feedback based on its performance and the user experience. To analyze our survey data, we use the arithmetic mean to determine the central tendency of respondent scores. The mean is derived by taking the cumulative sum of scores assigned by respondents on the Likert scale and dividing it by the total number of responses in the survey. Looking at the formula on the screen, the x bar represents the mean we are calculating. Sigma x is the sum of all the data points, and n is the total number of respondents. For respondents, to ensure that our system met the needs of every user, our survey targeted the key personnel within the inventory workflow: 1 super admin, 1 property custodian, and 4 office heads. That makes a total of 6 respondents who evaluated and tested the system.
So, as we are done with the chapter 1, 2, and 3, we will now delve in with chapter 4 for results and discussion. So in this part, we will discuss first how will be the interpretation of the computed mean. So us, the researchers, use a 5-point Likert scale. It has the numerical rating, range of mean score, and then interpretation. So we have 5 numerical rating. First, we will start with the 1, and the range of mean score of this is 1 to 1.80. Then, it has a poor interpretation. Next is for the numerical rating of 2. The range of mean score of this is 1.81 to 2.60. The interpretation is fair. Next is for the numerical rating of 3. The range of mean score of this is 2.61 to 3.40. Then it has an interpretation of satisfactory. Next is for the numerical rating of 4. For this numerical rating, we have the range of mean score 3.41 to 4.20. And it has a very good interpretation. And lastly, for the highest numerical rating 5, it has the range of mean score 4.21 to 5. So the interpretation of this is excellent. Next, we will discuss our overall result of system evaluation based on the evaluation of our clients and users for the system PUP-TIMS. So for the functional sustainability, we gained 4.80%. Next is the performance efficiency, 4.90. For the compatibility, usability, reliability, security, and maintainability, we all got a numerical rating of 5. Then for the portability, we gained 4.87. So for the overall mean score of our system evaluation based on the ISO 25010, software quality characteristics is 4.95. So it has a verbal interpretation of excellent based on our 5-point Likert scale. So for the testing documentation, we have here the summary wherein it will discuss when, who, where, how, and what was done with the testing. So for the when aspect of testing documentation, it started on October 4 and it is still ongoing. So who tested the system? The QA team in our group, and also the authorized users first. We have the super admin, which is Sir Amang, property custodian, which is Ma'am Gina, and for the office head, we considered Sir Amang as our user also and the office head, since he has the part of having the 3 offices, which is the Bayers, Aboitiz, and the DOST lab, where we conducted it in the PUP-Taguig offices such as the DOST lab, Aboitiz, Bayers, and also in the property office, and also in the medical. How we conducted it in a live production environment using actual users. It tested the functionality, usability, and the system performance of the hosted system. And for what the tested modules include login authentication, equipment management such as populating the system with the current inventory, QR code scanning. We already printed QR codes, we already generated QR codes, and then we implemented it to the DOST lab already, and the reporting and the user role management. For the chapter 5, we will discuss the conclusion and recommendation. So we have here the matrix wherein we have the problem, findings, conclusion, and recommendation. So for the problem number 1, the manual inventory process causes delays and data inaccuracy. So for the findings, that the previous manual system relied on logbooks or spreadsheets that results in misplaced records and inefficient tracking of assets. For the conclusion part, the implementation of PUP-TIMS revolved the issues by automating inventory management, ensuring accurate and real-time data. So for the recommendation part, continue using the system and provide training to staff, especially the property custodian and for the super admin, for proper utilization of its features. Next, for the problem number 2, difficulty in monitoring equipment status and availability. So for the findings, the system now allows users to update and track the real-time status of equipment. If it's still available, in use, if it's still working, or it needs to be repaired, or for disposal. Next, for the conclusion of it, the features improves transparency and accountability in handling university assets. So for the recommendation part, regularly update status records and conduct period system audits to maintain reliability. So for the problem number 3, lack of quick access to equipment details. So for the findings, the use of QR codes enables fast and efficient retrieval of item information. So for the conclusion, QR code integration enhances efficiency and reduces the time spent searching for records. So recommendation part, implement QR code scanner in all departments and ensure each item has an updated QR code. For the problem number 4, inconsistent reporting and documentation. So for the findings of it, the system generates automated reports for easier monitoring and auditing. For the conclusion, the automated reporting ensures consistency and accuracy of data across departments or offices. So for the recommendation, schedule regular report generation and data backups for record security. And lastly, for the problem next is the limited awareness and system adaptability among the users. So for the findings, some users require additional guidance in navigating system features. So for its conclusion, training and familiarization are essential for maximizing the system full potential. For the recommendation of this problem, conduct periodic orientation and refresher sessions for new and existing users, especially to the office heads. Lastly, for the implementation details, here's the calendar of activities. We had the orientation for the office head, super admin, and property custodian, introduction of the system and user training. It started on October 9, 2025. Then the partial implementation or the soft launch and deployment across admin only, and the super admin started on October 4 up to October 20. And for the full implementation, we scheduled it on November 8 to 14. It is the official launch and deployment across all the departments and all the office heads. And monitoring and support, it will have the continuous observation, user assistance, and issue resolution from November 15 to 30, 2025. And then for the maintenance and updates, it will be the activities for this will regular updates, backups, and performance optimization. It is scheduled started October 9 since October 9 to up to ongoing of the implementation of the system.